So we're going to have a look at 9D, which is graph of the derivative function. So we see with this first diagram we've got here, this is a parabola. So anything that's a parabola, we call that a quadratic. And if we take a derivative of a quadratic, so, say this was, I don't need to do it, but we would get something that's linear. So like if we went from x squared, that would go to 2x. So when we do the graph of the derivative, what's going to happen is this graph is going to be a straight line. So when it says x is less than a, what that's saying is before you get to a, what was the gradient doing? Well, the gradient, it was going down, it was negative. When we're at this turning point, the gradient was 0. And then after this point, the gradient is positive. So if I put this point a here, I know the graph of the derivative is going to be 0 because the gradient was 0. Prior to that, the gradient was negative, and then after that, it was positive. And it's just a little bit confusing because you think as you're coming down here, this is really negative, and then it gets shallower and shallower and shallower until it gets to 0, and that is essentially what's happening as we come along here. It's the gradient's quite negative, it's large in the negative direction, and then it gets to 0, and then it goes off and becomes positive and then more positive. So if we've got something that is a cubic, like this one, if we took a derivative of that, we would get a quadratic. So let's do the easy points. At A and at C, the gradient is 0. So at A, it's going to go through there, and at C, it's going to go through there because it's 0. Prior to getting to 0, the gradient was positive. After here, after we got to C, again it was positive. And we know it's going to become a quadratic. And in the middle here, the gradient was negative. So the gradient goes positive, negative, and then positive again. So this is the graph of the derivative. So let's have a look at some of them. So it just helps if you've actually got the graphs printed out, and I think I've put them in your booklet for you. So you see this one here, it looks to me, this would be a line of, I know what it is, it's going to be y equals x plus 1. So if I found a derivative of that, it would just be y equals 1. So the derivative looks like this. This would be a graph of y equals minus x plus 2, but it doesn't matter if you know that. You just, that's right. You just know that it was a negative gradient at negative 1. Rise over run. This one here, we know our cubic goes to a quadratic. Gradient is 0 at the turning points. It started off positive, negative, and then positive again. And then they get sort of a little bit more tricky. Sometimes you just got to make it up a bit. Look, usually the ones on exams, I've got some examples later, you can see the sort of graphs you get to do. But if you've got a point of 0 gradient here, gradient is here. We know this is a graph of x cubed plus something, I'm going to say 1. So the graph we would get left would be a 3x squared, which looks like this. The gradient is positive, then 0, then positive again. So if we look at my parabola, positive touches at 0 and then positive again. Similarly for this one here, this is not quite negative 0 gradient because this actually says here, so the gradient at this point, it might be like 1 or something. So we draw something like that because a cubic's gone to a quadratic, but the gradient never quite got to 0. And here we just have a quadratic. This could be something like y equals x squared plus 2. I'm not sure what the dilation is here, but if I found a derivative of that, it's just y equals 2x. So every time it goes rise over run, this would be, this point here would be 1, 2. Okay, so we know if we took a derivative of that, it would work. So there's lots of different strategies of doing it, and it all tends to come out in the wash. This is a special function called the modulus. We don't have to actually do that function this year, but you do need to be aware of what the graph looks like, because at this point here, that's called a cusp, that pointy bit, not a cusp, a cusp. So what happens with this one, if I've got, I'll draw a graph here. As I look on this bit here, the gradient is constant, and it's, I've drawn over it, 2. So we've got a constant gradient of 2 here, so I'm going to draw that on. I've got a constant gradient here of -2, so I'm going to draw that. And then we have to think, what is the gradient here? Is it positive or is it negative? Well, it depends which side you come from. If you come from this side, it's positive. If you come from this side, it's negative. So what we do is we say you can't find the derivative on that cusp. So that's what the graph of the derivative looks like for that function. So what I've got here is exercise 9D, not for me to do, but for you to do, because when you get to 9D, you don't want to have to draw these graphs in your book. So just use these slides here of 9D to actually do the work. So questions 1 and 2 are here. The rest of the questions are in the book and you can do them in your workbooks. And then you can have a go at those practice exam questions.